Okay, so in this session we will do the support vector machine. Okay, in the Python Colab means we will use the support vector machine to solve the some real life problem. Okay, so in the previous video means I discussed about the introduction part of the support vector machine. So now this is the best fit line which able to just assume that this is the best fit line which able to divide the data into the two part, yes and no. Now what support vector machine will do, it will draw the two, means in short you can say uh, two hyperplane, and it will be like the means one, the mid is the hyperplane and the side these two plane is nothing but we can say the marginal plane in support vector, and support vector will check where actually maximum uh, marginal distance means distance between the marginal plane means able to get. Okay, so like that means by changing the value the algorithm will check where I'm getting the maximum marginal value to divide this data into the two classes, training data. Okay, so once it get the means maximum distance means after that this means hyperplane we can use for the prediction purpose. So that is the entire thing. Okay, so now I will try to solve the one problem with the help of the support vector machine. Specifically we will focus on the you can say the classification problem. So means we will use the data uh, means these are the crop recommendation data, and there is the soil testing data is available. Here you can see the nitrogen, phosphorus, potassium, as well as the temperature and humidity, pH value, rainfall. So these are the independent variable, and label means you can say the rice and other. So these are the means you can say in short this label is nothing but the dependent variable for supervised machine learning, right? So this, on the basis of this data I just want to make the recommendation system for the crop that will give me the recommendation what type of the crop we need to do. Okay, okay, so now I will open the Google Colab quickly. Welcome to the Google Colab. I will click, then we will take the new notebook. Okay, and you will get the Google Colab ID here. Okay, and you can start the coding. What we need to do in the initial stage, so I need to import the pandas library, actually import pandas, and if I want to do the some visualization, then matplotlib and numpy. If I do the some numerical python, actually not required, but I'm just trying to show without writing any code also I can do the coding with the help of the generative AI. Now you can see all the code written by the generative AI. Just click. Okay, okay, so now I need to import the file from my. Okay, so file is available. Once you just need to click on upload and that file will be available here. Okay, the CSV file that means just we discussed, so that file will be available inside your Colab. You need to just copy the path. How to copy the path? Click on this three dot, copy path, and then just click here, and you can write import this file, right? And just click on generate. It will generate. Okay, so now the data inside your IDE, or I can say inside your Python platform. Now if I see what is the DF, I can see the entire data set, right? This means nitrogen, potassium, calcium, I'm sorry, nitrogen, as well as phosphorus, potassium, temperature, humidity, pH, rainfall and level. Okay, and now I want to make the crop recommendation system. There means label is available, and with the help of the supervised machine learning we can make the crop recommendation system. But this is the classification problem, because here we want to predict the categorical data as a output, right? So what I will do now, I will divide this data into the x and y. Okay, so I can say consider label as a y and others as a x. Then you can see x and y is created. X means your, in short, you can say the dependent variable, and y is the, I'm sorry, x is the independent variable, and y is the dependent variables. So now what you need to do, just click OK, and we need to divide this data into the train and test, right? So now you can say do train and test split. Okay, and then you can see the train test split you will get, right? So it is very easy now, no need to write any code. With the generative AI you can do entire thing. So now we have x train, we have x test, means now we divided the data into the training and testing. Training data we will use for the model training purpose, and the testing data we will use for the, you can say, testing of the model. Okay, or we will evaluate the model on the basis of the testing data. The next point here, now I will write make model, or you can say the logistic regression model on x train and x test. I'm sorry, x train and y train. I'm sorry. You can see now model is created. The iteration is means it will check 1000 times and you will get the model, right? Even we can increase that iteration also. But okay, here the focus is the support vector machine. So you can make any model, right? Any model. So now I will write support vector classifier model, right? And you can see this support vector classifier SVC means is done. Now what I will do, check the score of the SVC model. Okay, then it will give the accuracy score 96.13. That's very good. Now I can say that do cross validation for the model, for SVC model, right? And then we will get the cross validation value k-fold. Okay, and what is the means 5 times it will check, and yeah, you can see every time I'm getting the means good accuracy, the result is more reliable, and I can deploy this model, because every time I'm getting the 98, 97, even by changing the data also, the accuracy is not decreasing, means always it's give me the good result, and you can see the variance between this different data. When I pass, the variance between the results is not too much vary. So we can say the model is best for the deployment, right? And now what I will write, dump the model, right? I'm sorry, I will do that part with the generative AI. Pickle, and this is the file. Now you can see that model will be available. It will take some time, but it will available here. Just wait. So now you can see the model is available. We can download the model also, okay, in our local system, and then we can do the deployment part also with the help of the Streamlit and all. Okay, so now what is the next point I will write here? Do deployment with the Streamlit. Then we will get this script. Okay, that is script we can use uh, with Streamlit and use dumb model. Then the script will be maybe different. Yeah, it's different. Now you can see this is the script, and we actually need to do this in the local system. Okay, so when you write to deployment with a Streamlit and use the dumb model, then you will get this entire script with a Streamlit. And here you can see what are the suggestions. Save the code as a Python file, open your terminal and navigate to directory where you save the file and run Streamlit run app.py. Okay, so now I will do that entire thing. So what I'm trying to do here, I'm just click on the anaconda prompt. Okay, so this is the anaconda prompt, and there what I need to write, already I think file is saved there. What I need to write is Streamlit. Okay, I will check quickly the file, 1 minute. So okay, in this particular location you need to save that Python file. Okay, means .py file which suggested in the Google Colab. Okay, what I will do, just wait 1 minute. Okay, so you can give means this particular app related code you can save in the one, you can say the short note, or the .py extension you need to give, right? And now if I quickly show you the deployment part with a Streamlit, I know that code means what it is suggested. Just write the Streamlit run, and what is the name, actually I given the file name is crop.py, and their model location is also there, means I save that model in that particular location. And now if I run, so you can see the deployment, means now you can use this particular app. Here you can write what will be the nitrogen percentage, like suppose nitrogen percentage is the 2, and even I will write the 413. The phosphorus is even I can say 11 and 10, whatever. Okay, and the next I will write here the 3. The temperature is 35 degrees Celsius. Humidity is suppose 45. pH is suppose 3. Rainfall is 120. Then predict what the crop I need to do, mango. So these are the some suggestions. So like that I can make the crop recommendation system with the help of historical data, and the algorithm also giving me the good result that I already checked. Approx 97% accuracy I am getting after even the you can say the cross validation. So that's all about this. Thank you very much.